This video will show you how tutorials are used at the University of Colorado Boulder, where they've been part of the undergraduate curriculum since 2003.
Tutorials are a research-based student activity. They come out of the University of Washington's Education Research Group. They are workbooks, a few pages of largely conceptual activities. Often it's paper and pencil, kind of playing with some representation, trying to make sense of some element of physics that has been known by research to generate student difficulties.
At the University of Colorado, tutorials have replaced recitation. Sections of about 30 students work in small groups at tables in a modified lab space. At other universities, tutorials may be integrated with a regular class period.
The tutorials do a great job, and really a lot of thought and care has been put into them. And they really pull out essential concepts and focus on problems that students commonly have.
We have good discussions. We argue with each other a little bit. We try to come to a conclusion together.
So I'm a big fan of the tutorials. We have data that suggests that our students are learning better, and many faculty have cycled through this course, and almost all have expressed their appreciation.
At the University of Colorado, tutorials are facilitated by graduate teaching assistants, as well as undergraduate learning assistants, who are students who have taken the course in the past.
Both the TA and LA walk around because the students sit in groups in different tables, so like 4 or 5 students per table, and then help facilitate discussion.
I'm mostly just letting them work on their own. The time that I spend up front lecturing is very minimal.
Yeah, one thing I'm glad my TA doesn't do is give me the answer and then explain it. What he does very well is, kind of identifies where it is that I'm having problems understanding something, and then asks a lot of questions saying, well, what do you think about this? Or what if the situation was this instead?
Explain your reasoning there is a very good general purpose thing to get them talking and see what they understand and what they don't.
Well, what do you think is happening here? Or what did you do for this free body diagram?
How did you guys get this?
It's a little counterintuitive at first for many people. We all have a tendency to want to jump in and correct errors, and I think the tutorial really is designed to help the students self-correct if given the space. The one element of the tutorials that we have always struggled with is that the students are not universally thrilled with them. There's this sort of edge of, yeah, I agree they're helpful, but I didn't really like them. This is not the way they normally are taught, and they're not being told if they're right or wrong. Sometimes I will sit down with students and say, I'm not going to tell you the answer, but I guarantee you by the time we're done, you're going to know the answer.
It can be hard to find a way to direct them to the answer without just telling them the answer, and that's where it really helps to have prepared it beforehand, because then you really know the questions in and out. To prepare to teach a tutorial, we always gather as a group, all the TAs and the LAs.
And they're discussing and working through the tutorial just like their students.
We make sure we go through every single problem and know, of course, how to answer it, but then also we discuss what the common problems students might have are.
I walk around and I circulate and I look at what they're answering, and I'll ask them questions.
Invariably, every week, I find things that I realize I didn't learn as well as I thought I did the first time in undergrad.
The faculty members are equipped with student responses so that not only can you talk about the content, the physics content of the upcoming tutorial, but you're able to discuss student ideas about that physics content.
Where their students are going to struggle, and think about how they're going to respond to the students at particular things. What kind of questions could they have the students think through to help them with a particularly difficult point?
I have seen examples where the faculty pretty much focus on the physics content, and in those semesters, we don't get as good outcomes. So we're finding hints that, in fact, preparing TAs pedagogically and not just about the physics content is beneficial to the students in the class in the long run. It provides an environment that helps everybody. The faculty members think more about what's difficult about physics. The LAs learn more about what it means to teach. and the students are learning physics in novel ways.
Sometimes I feel like in lectures we get, the broad strokes, and in tutorial it really kind of allows us to dive in and really kind of get to the nitty-gritty of what a problem is about.